Hi, I'm Marcin Zabłocki. I'm MLOps architect at GetInData, and today, in the next couple of minutes, I will show you how you can run your Kedro machine learning projects on Azure Machine Learning Pipelines service and track the metrics using MLflow. So if you don't know Kedro, it's a framework that does a great job with structurizing ML projects from the perspective of software engineering. So it does not limit your data scientists by any means. They can use all the libraries they used to, like scikit-learn, XGBoost, TensorFlow, PyTorch, and so on. So Kedro, with its well-established abstractions, gives you ability to write and implement the machine learning pipelines only once and then run it on multiple execution engines. And at GetInData, we've open sourced many plugins for Kedro, such as Kedro Kubeflow, Kedro Airflow, Kubernetes, Kedro Vertex AI, and Kedro Azure ML, which will be the focus of today's video. And thanks to those plugins, you can easily port your machine learning projects from Kedro and run them on one of those services. So grab a coffee and let's dig in. So before you start, you need to prepare a few things. So first of all, you will need Azure subscription. You will need to create Azure resource group and a few additional services that are mentioned in the Kedro Azure ML plugin documentation. You can always refer to it and search for them using your favorite search engine. So as you can see here, we need to create ML workspace, compute cluster, and some additional things related to storage accounts and also the container registry. So in the Azure portal, I've already prepared all of the required services. So I have Machine Learning Studio, container registry to store my Docker image there, and also the storage account. And within the Machine Learning Studio itself, I've prepared a compute cluster. So you can go to the compute cluster and create one that suits your needs, and you will be good to go. Remember to store all of the names and keys and so on at hand, so you will be able to quickly go through the quick start. So once you have all of the values ready at hand, you can start coding. So in here, I have prepared Python virtual environment using Python 3.9, and I've already installed Kedro using pip here. So once I've installed Kedro, I can create a new Kedro project using Starter, which already has a simple machine learning pipelines for us to work on. So the Kedro new command will guide you through the setup process. I will name my project Azure ML Demo. It takes a few seconds to install, and once you're done, you will see that it created a new folder with your project. Here, when you open it, you will see full Kedro project that was prepared for you. It has all of the things that Kedro developers are used to. So before diving into the project deeper, I will run Kedro visualization command in order to visualize and show you what does the space-size starter look like and what is inside this project. So in this visualization, you can see the Kedro pipeline. It consists of two sub-pipelines, data processing one and data science one. Data processing one is the one that actually takes all of the input data sets, processes them, and creates the table for our model to work on. And in the data science pipeline, we have actually two sub-pipelines. The first one is active modeling pipeline, and the second one is candidate modeling pipeline. Those two are the same from the code perspective, but they differ in parameters. So you can imagine that data scientists want to work on multiple versions of models at once, and they can try it out easily with Kedro. So in here, when you dive deeper, we are taking the model input table that comes from the data processing pipeline, and we are processing this data, splitting it into training and testing sets. We are training the model, which is a regressor in this place, and we are evaluating the model. And this is how the pipeline looks like from the high-level perspective. And remember this image because we will soon see it again in the Azure ML Pipelines once we run the pipeline. One additional thing that I need to do is to install Kedro Azure ML plugin. So I'm using pip to install Kedro Azure ML plugin. Once it's done, you will get additional set of commands So while you are in the Kedro project folder, you will be able to run Kedro Azure ML with, for example, help, and it will show you all of the commands that are available for the plugin. The initial step here asks you, it's a matter of Kedro framework itself. It asks you whether you want to opt into analytics. For our demo, I will opt out. So in here, you can see all of the commands that are available for Kedro Azure ML plugin. So what is of our interest right now is to initialize our plugin. So I will run Kedro Azure init, and obviously without any parameters it will fail, and it will show you a helpful message what kinds of parameters you need to take in order to initialize your project. So as you can see in here, we need resource group, workspace name, experiment name, cluster name, storage name and storage container, and later on we'll also need storage account key and also subscription ID in order to run the pipeline itself. So obviously for the demo magic, I've prepared all of the initial values that I need for my project before, so I can just run Kedro Azure ML init command and it will create the basic configuration for me. What's important here is that it's a note in the console that it's good to set lifecycle rule, because all of the intermediate Kedro datasets will be stored in Azure Blob Storage, and sometimes you will not. It will be not desired to store them for infinite amount of time. You can clean them up after a few days, for example. It depends on how you want to manage your storage. So yeah, once it's done, in the project structure, in the base configuration folder for Kedro project, you will see that I have this Azure ML YAML file that contains all of the values and descriptions that I've gathered during the setup. So this is the place where you can, for example, modify your cluster, modify your experiment name, and so on. Okay, so in order to run this demo on Azure, I need to modify a few things. First thing will be to add Kedro Azure ML into the requirements. And since I want to also use MLflow, I will need to add this extra requirement of MLflow, which automatically instructs our plugin to add MLflow for track. Once you modify the requirements file, you can just type in pip install with requirements, and it will install all of the dependencies of the project itself, and also our Azure Machine Learning plugin in your virtual environment. The next step of preparation is to initialize the Kedro Docker. So you need to install Kedro Docker plugin in order for you to quickly set up Docker file for your Kedro project. Once the plugin is installed, you can type in Kedro Docker init, and underneath the hood, it will initialize some files related to Docker for you. So one of those files would be obviously Docker file, which contains all of the build procedure for the Docker image, and also the Docker ignore. This is the file that you need to modify. Since we'll be running on Azure, which will be a remote machine, we'll not have access to the data, and default configuration of Docker or Kedro Docker plugin actually removes this folder from the Docker image. So what we need to do is to allow this raw data folder to be present in the Docker image. Okay. Next thing that you need to do is to modify the data catalog. So data catalog here by default points out to different data sets, but for our needs, we don't need to store any intermediate data in order to run our pipeline on Azure ML. The plugin for Azure ML Pipelines captures all of the intermediate data by itself, and it stores them as cloud pickles on Azure Blob Storage. So what we need to do here is to modify the catalog to only point to the raw input data sets that we included in the Docker image before. Okay, so I mentioned at the very beginning that we'll be not only running the pipeline on Azure ML Pipelines, but we'll also run and track our experiments using MLflow. So Azure ML Pipeline service by itself is really tightly integrated with MLflow, and you can use plain MLflow abstractions to track your experiments, to store your models, store your artifacts, and also trace your metrics. So in the source of your project, you will see the pipelines folder and data science folder. And you will see that data science pipeline available here, and it has a few things. It has splitting the data, training the model, and evaluate model. So first of all, I would like to add MLflow here. So let me import that here. Import MLflow, great. And now, first thing that I want to do is to actually store the model as an artifact. So what I can do is, since I'm using scikit-learn in this project, I can enable autolog for my project, and it will instruct MLflow to track all of the models that I will be training in this scikit-learn framework. So that's a thing here, and additional configuration in the evaluate model. When I actually test my model on test set, I can also log metric. Since R2 metric is used in here, I will just log it into MLflow. And that concludes all of the changes that I needed to do in the project itself before I build the Docker image. Okay, so once you're done with those changes, you can actually build the Docker image. So first thing that you probably want to do is to copy the Docker image tag that is in the configuration, because that is the Docker image that will be actually running. So let's go back to the terminal and just type Kedro docker build with the Docker args. And as you can see here, I will be using Python 3.9, which is the same that I use in my virtual environment. And also I've pointed out that I want to tag my newly created image using the same image tag that is stored in here in the Azure ML YAML file. So once you run it, it will create your Docker image, and it will definitely take a few minutes. So be patient, because there are a lot of requirements in your project, and all of the packages need to be installed first. Okay, so thanks to the magic of videos, the build time, which took 247 seconds, took only a few seconds for you. Once the Docker image is built, we'll need to push this image to the actual container registry. So first, you will probably need to log in first. So you can type ACR login. It will create Docker credentials underneath the hood that will allow you to push the image into the Azure Container Registry. And once it's done, we can just type docker push, and it will push the image. And as you can see, again, it's a long-running process. It has almost 1.5 gigabytes, so we'll need to wait a few minutes to push it up. Okay, so once the Docker image is pushed, we can run our pipeline. So for that, I will type in Kedro Azure ML run. We need to pass subscription ID and hit enter. And in a few seconds, the prompt will ask us for the Azure ML Azure Storage account key. I have this at hand, so I will paste it here. But if you run your pipeline using CI/CD, you will be able to set this key as a secret environment variable, so that the plugin will not prompt you to provide this value interactively. And once we provide the key, we'll wait a few seconds for the plugin to compile the Kedro pipeline into Azure ML pipeline. And once that process is complete, it will schedule and run the pipeline on Azure ML Pipeline service. And once it's done, you will see the URL to the pipeline, and you will be able to view this in the Azure ML Studio. Kedro Azure ML command has also one additional parameter useful for CI/CD. So it's named wait for completion. And once you add this parameter, the terminal will block the execution from exiting, so that you can, for example, wait for the Azure ML pipeline to complete, and the plugin will also propagate the exit code. So, for example, you can instruct your CI/CD pipeline to wait for the Azure ML pipeline to complete, and also propagate the status of the pipeline. So as you can see in here, the pipeline has started successfully. So I can click the link and it will open my Azure ML Machine Learning Studio. And soon enough, we'll see the pipeline executing. As you can see, a few steps have already passed. And what you can see in here is the almost one-to-one mapping to the graph that I showed you before. So all of the functions that involve processing of the data or training the models that are Python functions in Kedro pipelines are one-to-one mapped to the things that we can see in here. So you can see the data preprocessing nodes and creating the model input table, which is the place where we join our data for training. And here you can see two separate branches which map one-to-one to the sub-pipelines, the active modeling pipeline, and also the candidate modeling pipeline. And as you can see, the execution proceeds pretty quickly. Once you click the node, you can, for example, see the user logs, which are really useful when you are logging something in your standard Python logging from your pipeline. So all of the logs that you log in the pipeline itself will be shown in here in the user logs. System logs will show you some internal Azure ML Pipelines thing if you want to debug some, for example, performance issues and so on. Let's wait for a few seconds more for the pipeline to finish. So here we can see that one of the steps that actually trains the node is starting to execute. In a few seconds, we'll see that the logs are already here. Yes, so the step is almost finished. And when we switch to the metrics tab, we'll be actually able to see all of the metrics that were tracked during the model training. So those are the metrics calculated on the training dataset for our model. And soon enough, we'll also see the metrics from the test set. So as you can see in here, the R2 metric that I've logged manually using MLflow log metric is displayed in here. And going back to the model, you can see that the metrics were tracked, but also in the output section, you will see that the additional folder was created and it says model. So this is actually serialized model that we've trained. And this is MLflow compatible model, so you can use standard MLflow procedure to move this model to production. You will be able also to register this model and deploy it later on in the Azure ML endpoints. So all of the integrations with MLflow are seamless to use, and you don't have to set any additional parameters for the MLflow. Azure ML Pipelines does the job for you. So every metric will be tracked, and you will be able to see them in the nice visualization from the Azure Machine Learning Studio. So that concludes our quick start of running Kedro project using Azure Machine Learning Pipelines. I hope you like it. If you encounter any issues, drop us a message on YouTube comments or go to our GitHub into Kedro Azure ML project, drop some issue there. We'll be eager to help you. Hope you like our video, and I encourage you to subscribe to our channel to see more videos like it in the future. Bye.